Yeah. So Computer Science 4300, we're going to be doing some C++ game programming. Not a lot of content in the first lecture, like in terms of the actual course content, but I just want to go over all the stuff I've posted to D2L. I'll go over the syllabus, how the course is going to work, and then like sort of a brief introduction, an overview of what the course is going to be. At any time, if you have any questions, feel free to raise your hand. Just don't yell it out. That's all. All right, so let me just go through the D2L post that I made so that everyone can get all the information. I'm sure everyone already read it all already, but I like to go over it just in case the lecture capture happens to work. We'll have it on the video for people who are not here today. So hello, everyone. Welcome to COMP4300. Thank you for registering. Our course will be, this term will be in-person lecturing. Oh, there's no exams, so that's a typo. So it's good that I actually read this out. I copied it. This is a copy and paste error. So right, I did my other course first, and then I did this one. So it's good. There's no in-person exams. There's no real in-person evaluation at all, other than submitting assignments. But you don't do that in person. So here's all the info for the course. So of course, Tuesday and Thursday in this room from 10:30 to 11:45. And of course, some classes may go 5 minutes late, some may be 5 minutes early. We'll be in this room. I am not a gigantic fan of this room. I don't particularly love the double screen. I wish it was a single screen here. Oh, Jesus, I'm not even recording. All right, so that better? Hear it a bit better? So the video will start here. So yeah, we're in this classroom. I wish this classroom had one bigger screen rather than two smaller screens, because as you can see, even with a decently sized font, it's a little bit hard to see in the back. Of course, the lectures should be captured, and the screen should be visible in those lecture captures pretty easily, so hopefully that will work properly. Today is the first class. We have a Google spreadsheet. Who has taken a course with me before? Okay, so you pretty much know how it's going to go. So about half the class, you know that there's a spreadsheet, and I'll link to the stuff on the spreadsheet, etc. So the course will make use of D2L, my website very minimally, just for links and stuff, and Discord, which is completely optional, but it is sort of like a community on there. We can ask questions and answer questions on Discord. It's by far the quickest way to get a hold of me, because I just live on Discord. It's kind of sad, but if you're a prof and you program and you play games, you're just on Discord all the time, right? But just a mention about Discord is that there is just have no reasonable assumption of privacy on Discord. Like, you are posting publicly, probably something to the channel. Assume everyone in the world can see what you're saying, okay? I am not responsible for Discord's privacy settings. That's all I'll mention up front. If you PM me, I am not going to intentionally send that to anybody, but if there's a police investigation, they can probably see those messages. So Discord is a company, it's a for-profit thing, you're using their terms of service, so that's out of the way. If you do not like that, emailing me is always fine, or coming to my office hours is always fine. All the course content will be linked on a Google spreadsheet, which is updated after each lecture. So just give it a day. I've never used lecture capture before, because I've always done my recording at home, like streaming my lectures. So I don't know when this will appear. I've been told it should be by the next day. So just assume that you're going to have 24 to 48 hours lag on when the video is available. Links to the Google spreadsheet and the course syllable can be found on my teaching website, which is here. I'm going to put out a little poll on D2L. I like being able to post my lectures publicly on YouTube. I find putting the timestamps and stuff in the YouTube video is just way better for students. But if you ask a question in class, this mic may pick up some of your voice. Okay? I will not be posting the video stream, only the presentation stream publicly. But I won't do that until I've put out a little poll and everyone says they're okay with that. I think it's just an easier way to consume the media. But I'll put out a little survey. All important course announcements will be made via D2L. Apparently, there's a setting on D2L that lets you enable email notifications for D2L posts. So if you set that up, then you'll never miss any important announcement. I will be making some like @everyone announcements on Discord, but typically if it's something important, then it will link to the D2L post. So if you're only following D2L, you'll still get all of the course information. You don't have to be on Discord. So the people who've done this with me before know how you're going to get your assignments. So everybody will be individually emailed a link to your @mon.ca address where you can download a personal copy of each assignment. Okay, so there's not like one zip file that you download. I actually personalize each zip file for each person. You get a link, and then you download that. So all the assignments are submitted via D2L as a single zip file, and I'll show that in a little bit and explain it. And because not everybody, and I never single anyone out, maybe nobody in this room, but there's always people out there who want to ruin it for everybody and post stuff online and cheat and stuff. And so what I do is that in the assignment files, both in the plain text and the metadata and some hidden data in the files are data that can trace that file back to you individually. Okay? So if the assignment ends up on Chegg, I guarantee you I'll know who posted it to Chegg, okay, or any of these other websites. And I don't want to have to do this. It's a lot of extra work to do this. I had to write software to create these zip files and stuff. But it's necessary because since I started doing it, I haven't found it online, which is really nice. And I regularly have like searches monitoring this stuff. And also, please know that anyone's assignment found publicly online, please don't post it. Like if you're using GitHub to work with your partner, that's fine. Just make the repo private. And if you forget the first time and like assignment 1 is there and I find it because I just regularly search for it, I'm just going to tell you to make it private. I'm not going to like have you expelled or whatever. But even after the course, please don't just post all your solutions to your GitHub. I have in the past issued DMCA requests to take down people's solutions that they refuse to take down because the assignments are my copyright, right? So I don't want to have to do any of that, but it's necessary just to keep the course running because I can't make a new course every year. It takes months and months to make these assignments. Okay, so just realize that don't share your URL with anyone, but you can share your like assignment code with your partner. There's nothing wrong with that, right? If you're working in a group, which you can work in groups of up to 2 people for the assignments. It's perfectly fine to share that back and forth, but just don't share it with the public. So all the assignments are going to be done using C++, SFML, and IMGUI. So I'll talk a little bit about IMGUI in a couple of lectures, but this is the first time this course is going to be using it, and I'm excited about that because even though it's a little bit more to learn, it will actually make the project easier. So it's this weird thing where like you have to learn a little bit more, but the time that saves you in the end by knowing this GUI library that works really, really well with OpenGL and SFML, it's really cool. So hopefully you'll like that. So please don't use ChatGPT or Copilot or automatic code generation software. I know that there is absolutely no way for me to 100% police that. I'm not an idiot. Like I know that you could get away with it. However, if there's certain ways that I teach things and certain ways that I present algorithms like within the slides, and if I've like taught something a very specific way and it's by far the most efficient and easy way to implement something, and then the TA comes to me and it's like, Dave, this person did something that was like, you've never taught anything like this. It's like quite obviously done by somebody else. That's when we get suspicious. And so just know that in this course, unless otherwise stated, and it will be stated at some point, like in the project, if I'm going to have some like bonus marks for the project. So typically, if something is a bonus, I don't care how you do it. But for the actual like 90+% of the assignment that I say that you have to do yourselves, please don't use that software. If you do, and you're caught doing it, I will be treating it as if you had paid somebody else to do your assignment for you, and all the academic things that come with that. And I hate having to do that, but some people do it, so I have to mention that. There's like, and every year, there are excuses for things and reasons for not doing things. So there will always be a valid excuse to not submit an assignment on time. If you're sick, you get COVID, a relative dies, something happens, and you need an extra day, email me, right? Email me, we can work it out. There's always an excuse for that, but there's never an excuse to cheat. Okay, so it's one warning, it's upfront, and if it was up to me, like it usually is, but detected, provable ChatGPT is just a 0 in the course. Okay, and then you'll have to go argue with the university about that. So that's the last I'll say about that, but I know some people are allowing ChatGPT this year. This course is not one of them because it's a programming course, and if it does it for you, there's no point in learning. And you really are, like, I like to be good at things, right? I don't know about you, but if you go into an interview later and you've done this whole course, I've gotten a number of people in industry email me and talk to me on Discord and stuff who are actually like hiring at different companies in town, and they're like, all these students who are applying for these jobs keep submitting like your project work for in their resumes and stuff. So we'll get into that later, but like knowing this, being able to explain what you did, like that's going to be able to get you a job. Not this course alone, obviously, but the fact that you learned it rather than the fact that you copied it from somewhere online. So even though, yeah, school is annoying sometimes, you've got a bunch of courses. That's why I polled who was doing 5 courses, because this course is a lot of programming, right? It's a lot of programming, but hopefully you'll learn a lot. And if you do it, you'll come out the other side a better programmer, and that's the whole point, is to learn, right? So that's all I'll say about that. All right, we have a Discord server. Who's joined the Discord server already? I know there's a few people on there. Did the questionnaire work when you sign up for the server? I know some people were already there. You saw some questions and it gave you like channel permissions and stuff. So new on the Discord server, you gotta say which course you're in, and based on which course you're in, it'll give you access to send messages to those channels. So if you sign up as COMP4300, no matter what you sign up as, you'll be able to read the whole server. You can just go to the server and say, show all channels. That's fine. But you won't be able to post in the class channels unless you actively have the tag for COMP4300. So that's just like an extra layer of security, because a couple of terms ago, some previous students who were no longer students were like answering questions and stuff for people. And I don't want that to happen. I want discussion amongst us, not people who have already done the course. So even though it's not required, it's usually pretty active, and it's the quickest way to get a response from me usually throughout the day. I can't promise that I'll always immediately respond, but if I'm there at the computer and I see the message, then I will do that. So I think it'll help throughout the term. You can like talk to your peers if you're looking for a partner for the assignments or for the project. It's a good place. There's an looking for group or LFG channel there on the Discord if you want to talk to people. But of course, this year we're back in person, so you can talk to people here as well. So this is the Discord invite, but don't share that publicly. Well, I just shared it publicly. I forgot, I'll change that link eventually. Also, just set your nickname on the server to your real name. That's annoying. So that I know who you are, because it's kind of hilarious, like getting a PM from like Blaze at 420 asking about the assignment. Your Discord nickname is like, it's fine, but just change it so I know who you are. Would you able to, can you close that window just to see if that makes the noise a bit less? As I said before, oh, it's better, thank you. A little bit. So all lectures will be recorded by both this camera and it'll be recording the screen only. So I have not used the system before, but by next week we'll know how it all goes. So I'll talk about that more next week, and you'll see it. It will be posted to D2L, and if all works out, I'll also have a little YouTube playlist of just the screen, so it'll be easier to watch. So all the lecture slides will be available on D2L. So if you've taken a course with me before, you know this, but if you haven't, you might not. There's no real need to take notes in the course, because anything you see will be on the video, hopefully, but also I will release the PDF that of the PowerPoint presentation. So if there are animations or videos in the PowerPoint presentation, you won't get that, but you will get the text and the PDF for the course. And sometimes, like, okay, I say we will not miss any scheduled lectures. If there's another strike, which I don't think there will be, there's obviously a possibility that a lecture will be missed. But what I mean here is that if there's like a snow day, or I don't know, COVID comes back triple or whatever, if we can't come to a live lecture for whatever reason, I'm just going to record it at home and post it, just to keep the class schedule going, okay? And just to let you know, and many of you probably already knew this, my YouTube channel does contain lecture videos of a previous offering of this course. You're free to watch those videos if you want. However, those videos, you have to know, they're from last year. And things will be changing in this course. So, for example, all of the assignments in this course will have something to do with a user interface that was not in the previous offering of the course. There will be a lecture in this one showing off that UI library, which was not in the previous offering of the course. And anything I say in this class supersedes anything I said in that class, okay? So if you want to watch it for whatever reason, that's fine. But just know, like, you know, saying it up front that obviously this offering of the course is the one that you're taking. So if you saw it in a previous year's video, it may or may not be true. There are no exams in this course, so that's good. That supersedes what I said up there. Just 1 second. And the class will have a large final project that is worth a significant amount of the total grade of the course, and I'll go over that when I go over the syllabus. Yep.
The spreadsheet has an exam on it. The course spreadsheet.
Okay, well, I'll go over the course spreadsheet now, and that's probably just a copy and paste error. So don't worry about that. There is like an insane amount of stuff to prepare for new courses, so I'm going to miss a couple of things. But what I say in class always goes, not what's there. All right, so just quickly before I get into things, announcements. Okay, so I zoomed in too much, so you can no longer see the navigation bar, apparently. But yeah, when you submit your assignments, you're going to be doing it here. So just like any other course, I'm sure you've done this before. There's an assignments thing, and I've set it up so that you know all the due dates for everything already. So the calendar over here, as well as the spreadsheet, will show you the due dates of the assignments. I'm not exactly, like, late submissions are like a kind of a case-by-case basis if you had an excuse. But the one rule I try to say to everybody is, yes, there can be excuses for needing extra time, but the excuses are not valid if you come to me on the day that it's due. So if you message me the day that it's due, when you've had 3 weeks to do assignment 3, there is no sympathy and there's no extension. Now, obviously, okay, if you're in a car wreck or something like that, that's different. But if you just say, on the last day, I need more time, sorry. You had to come to me to show me that you had done something, right, throughout that 3-week period and then needed some extra time. So that's just the one rule. Come to me as far in advance as possible if you're going to need extra time with stuff. All right. And in the content section, that's where we're about to look at down here is a little shortcut. Important files. And you can see the outline. Okay, so this is the syllabus. Is there a full screen thing here? What does this do? Ah, well, that's useless. Okay. Let's just try and scroll right here. Okay, so this works. We've said a lot of this stuff already, so I'm going to skip down to the marking section because that's what I haven't talked about. So the evaluation structure for the course, the assignments are worth 40% of the course in total. And you can do the assignments in groups of up to 2 people. So you can work solo or you can work with a partner. There is no obligation to work with the same partner for every assignment, but as long as everything goes smoothly, I would recommend that so you kind of get used to each other's style and communication and stuff like that. I have designed the assignments to be done in groups of 2. So there's some keeners out there who love doing everything on their own, and that's fine. Just realize that it's meant to be done by 2 people, so it may be a significant amount of work for a single person. The final group project is worth 60%. Last year it was worth 50%, but this I think I rebalanced it because the project, it's what the course is about, right? And the project, like as we go through the course, and I'll talk about this a bit in the slides as well, we build and build and build our game engine as we go out throughout the course. And then the whole point of the course is to build a game with that game engine. And the game is going to be significantly different than the assignments in the course. So I have gotten some disappointing projects in the past where like it was basically like assignment 3 with different textures. People like reused the levels that I had made for the assignments, and like I made those things. I know if you copied them, right? So the project really does have to be different in scope. And so once we progress through the course, about halfway through, we'll have this thing where you get your group together. So the project can be done in groups of up to 4 people, and that is, you know, the expected amount of work, up to 4 people. And I know that some people really dislike group work. Get used to the rest of your life working with people, dealing with people, right? And that's part of the evaluation of this course is can you work with other people? I have in the past had, I think, maybe 2 or 3 people in the 5 years that I've been doing this course do the project solo. I wouldn't recommend it. Those people were doing, this was their only course, okay? So I wouldn't recommend doing that. And this usually scares people, but don't be scared because it has never been the reason for failing this course. But so you must pass the final project to pass the course, okay? So if your grade on the final is less than 50, that's what you get in the course. The assignments basically don't matter. And the reason for this is that the project is basically the whole point of the course, right? So you can't just get 100 on all the assignments and then do 10% of the final project and pass the course, okay? Now, like I said, nobody in the history of this course has ever just failed the final project and failed the course, okay? If that happens, I have always worked with those people to see what the problem was, possibly an extension in extenuating circumstances, and if those people really, really just did no work and just said, screw the project, then yes, okay, they failed. But it's not like, hey, I worked my butt off on this and I got a 45, I immediately fail the course. That's not going to happen, right? So this is only there to make sure that people understand that the project is the real point of the course, okay? And if you ever have any questions about any of this, just let me know. If some huge life event happens and you have to miss an assignment, we can reweight things or whatever. As long as people come to me with genuine needs or genuine, like, hey, this thing happened and I need more time, I've always been accommodating for that. But if you're like, if there's 3 hours left in the due date and you come to me, that's when I'm like, okay, I was a student, I know what that is, right? So, yep.
What's the rubric for grading the assignments?
So there will be a marking scheme passed out with every assignment, with very detailed, like, this is worth 5%, this is 15%, this is 20%. But do you mean like how much is each individual assignment worth?
No, just
okay.
how they will be graded.
Yeah, so there will be a text file that shows you exactly what you have to do in each assignment. And also, on D2L, if you go to the grades section, it will show you the weighting of all the assignments. So for example, like assignment 1 is worth the least because it's the least amount of work, because it's just getting used to C++. And there have been, over the years, like hundreds of students who had no C++ knowledge coming into this course who did fine. So if you have never used C++ before, I understand that C++, just the mention of C++ can be really scary. That's old C++. Okay, once you get the assignment environment up and running, which is pretty easy but takes a few minutes, especially on Windows, it's a little bit longer in Windows. Like modern C++ is as easy to program as any other language. It's really nice. Did I see? Yep.
Are the group members going to be automatically assigned, or we have to choose our group
Nope, it is up to you. So if there are several people who cannot find partners for whatever reason and want me to assign partners, I'd be happy to do that. I'll just go on random.org and assign people randomly. So I can do that, but you are perfectly free to work with whoever you wish in the course. Yeah?
Okay, one more on that. You know how when you're in groups, some people slack?
Yep.
How are you going to handle people who slack? So if we have
That's never happened in the history of this course.
3 people, 4 people in the group,
Yep.
and 2 people are slacking, the other 2 people have to pick up the work, are you going to deal with that anyway?
So that happens every year with multiple groups. And the solution to that is communication. And so if there is, if you have meetings with the group and it is obvious that 1 or 2 people in the group are not pulling their weight, this can be for a number of different reasons. It can be because that person is just slacking off and not caring about it, which is unfair to the group members. I have had people in the course who had family members pass away and did not want to disclose that to their group members because they, didn't want to share their personal life. So they came to me, said this stuff, and we talk it all out. So if you ever notice that someone is not pulling their weight, or for example, if there was a partner who promised to do this part of an assignment but never did, just come to me and talk to me, right? You'd be surprised at so a little bit of my background, I did 15 years of university, right? I had a 5-year undergrad, 3-year master's, 7-year PhD. I know all about working with other students. That's not bragging. It should have taken less time than that, right? I was a student for a long time. I understand how frustrating that is, but you'd be surprised at how often something that is really frustrating and you oh, that person's an ass or whatever, they're not doing their work, is just a genuine misunderstanding. And what I typically do is I send an email to all the individual members of the group. I say, hey, someone in your group has said that there may be a disparity in the amount of work being done. Just tell me your story. And from that, we work it out. And there's been only 1 case ever where people couldn't work it out. And of course, if someone ends up dropping the course, that's unfortunate. We can reassign groups and stuff if that happens. But it's not overcome. It's not something that we can't overcome. But the key to that is to come to me early. Now, if they if they miss 1 Discord message, don't all of a sudden start messaging me. But 1 person had moved in the middle of a course and didn't drop it and didn't tell any of their team members, right? And then the other group members waited until 3 days before the project was due when they hadn't heard from this person for 2.5 weeks. So that's a little bit much, right? I've got to be able to have time to do something. And if it ever comes out that we tried to work, and these 2 people in the group did all the work, and it's provably so, and the others admit just yeah, I had stuff going on, I couldn't do it, then we can talk about assigning different grades to different group members. There's no problem that communication can't fix. So I'm not just saying, okay, it's the Wild West. We're going to actually communicate and talk about it, because that's a skill that's required in a workplace as well, right? So this is all about, actually being programmers. Yep.
For the final project, will we have iterations, or is it 1 final submission?
So I will get into that more later, but there will be a project proposal where you propose your game. I look it over and say whether or not it's enough work. Then there will be a project demo, which is 2 weeks before the final due date, where you have to have at least half of the stuff done. And then there'll be a final project due date. So I'm trying to keep people going as we go in the course. But just keep in mind that you're going to have about 25 to 30% of the project features done in the assignments, right? You just have to turn it into a different game. So one of the features required in the assignment is some sort of gravity, right? Well, that's done in assignment 3. So it's not you're going to be starting the project at the end. You're going to be taking the game engine and making your project around the game engine that you already have. Now, yes, there will be some new features that you haven't done in an assignment, but that's the whole point of the project, right, is to make the big thing. Yep?
I have 2 questions.
No. In your project proposal, the projects will all be done on GitHub, and I have a GitHub template repository that you're going to copy, and then everything project related, including the group members' names, is going to be in the single GitHub repository.
Okay.
Yeah.
Perfect. And the second question in regards to the cheating, I guess.
Yeah.
If we get stuck and we reference the textbooks which are listed in the syllabus, or we reference API docs or anything like that, do you want us to cite them in the code where our solution came from?
So if you didn't write something yourself, please cite it. So everybody here is going to use Stack Overflow at some point. Like, how do I sort a vector in C++? You're not the first person to write that line of code. For little stuff like that, you don't need to cite it. But if you're like, hey, I got these shaders for the project from this website, of course, right? And so I'll mention what is copyable, what is not. But yeah, just don't use software that writes code for you. That's what I'm getting at. Yeah. Yep. Now, hold questions to the end because I've got some slides that I want to show, and I'm kind of behind on schedule. So, and again, this is the class spreadsheet. If there is final exam, nope. Okay, so I'll just write that there for now. There's no final exam.
It's also like 2 months ago, or actually like 4 months ago.
There we go. All right. That typically, yeah, so for my other course, I have an exam. That's where I list it. Usually what I do here, I was supposed to list when the final project was due. So I don't know it offhand. But here is the spreadsheet. It shows the whole class and all the lectures. I will link to everything here, but it will also be on D2L. And in fact, these links, the PDF and the D2L link, will just link to D2L. Okay, so it'll take you there. So I like having this because this is how I keep organized. And if it helps you keep organized, great. If not, you don't have to use it. You can just use D2L. Okay. So a lot of this has been said already, but I did want to show some other stuff. So this course is really an emphasis on the programming. Okay, so a lot of people think that this might be a game design course. I've had people, oh, I'm taking your game design course or your game making course. It's not necessarily that, right? There's game design, and then there's game programming. So a game designer will tell you what to program. We're not going to be going into what makes games fun or different mechanics. Like, we will talk about mechanics and how to implement them. But basically, you're the programmer at the company, and the game designer has come to you and said, make this. And this is how to make this, okay? I was thinking initially about like possibly combining those two ideas, but I really want to focus on the programming here. So it's the programming that makes video games possible. So we'll be talking about game engine and gameplay programming. And we will be making a 2D game engine in this course because if you've ever done any 3D game programming from scratch, 2/3 of the course would be just getting 3D programming up and running. It's a lot more annoying. So it's just 2D game programming, but you can take the same concepts and apply it in 3D. Like 90% of the stuff we'll be talking about, you'll be able to do in 3D. I just didn't want to overcomplicate the course. C++, SFML, and IMGUI are what we're going to be using, and I will have a lecture where I show how to set all those up. And it's not a game design course, but we may mention game design concepts, and it's not a Unity tutorial course either. So the course structure, lectures, there's no mandatory text. The lectures are everything. Okay, so basically everything you need to know will be in the lectures. That's how I try and structure my courses, but those texts that are listed in the syllabus, they are optional and you can refer to them if you want. I have taken some things from those texts and put them into the course. You can always email me and chat with me on Discord. I've said that already. I've said this already, and I've said this already. Oh, that's 4. Sorry. There was a year when it was 2 people, but that was kind of a disaster, so we're going back to 4 people. So many students have completed the course with no prior C++ knowledge. Next week will be entirely C++. So I will give lecture slides, and then I'll be programming. Hopefully you can see what I'm programming up here. Assignment 1 lecture will also be a tutorial on how to set up our development environment. So if you're using Mac or Linux, I've given you a make file. You can literally just type make. I actually don't recommend using Xcode if you're on a Mac. You can set it up, but I will be offering 0 support for Xcode. Okay, I've given you a make file. You can use any text editor you want and make, or you're on your own for Xcode. In Windows, I will be giving you a Visual Studio project file. So it is not VS Code. Microsoft is insane. VS Code is not Visual Studio. Visual Studio 2022 Community Edition is free. We'll be setting that up and using that for C++. It has the compiler built in. Once you have everything set up, like when it comes to assignment 2, you download the zip file, unzip, double-click, run. It works. Assignment 1, you'll have to set it up, of course. Don't be afraid. Modern C++ is awesome. Old C++ is not so awesome. Cheating and plagiarism, already said all that. Course goals, game programming from scratch. I think you'll be pretty proud of what you've made by the end of the course. You want to learn the ECS programming architecture, game programming patterns, and some software design principles that make things easier for you overall. And we're going to implement several different games. And then by the end, we'll have something, this is just something I whipped up just as a demo, where we'll be able to make a game like this with animations, projectiles, tiles, explosions when things happen. What else happens here? So you can like click and drag around tiles, edit the level live while you're doing, like all sorts of cool stuff. And like, you may say like, how would you do that? But in like 2 months, you'll be like, oh, that's really easy. Give me something hard to do, right? And so, in my opinion, the ECS architecture makes this like trivial to do, and it's a really cool architecture. Of course, the question is, many modern game engines exist. Why would you do everything from scratch? So we could have used Unity, Unreal, Godot, whatever. And these typically have some user interface to interact with, along with coding as well. So you can code, you can use like blueprints, you can do scripting, all sorts of stuff. And so, here's examples of game engines. Who has made a small game with an existing game engine before? Anyone? Oh, perfect. So you all know, or most of you know what this is like. So you can have like level editors in the game. This is one that like you're building a road here, and I think this is an old version of Unity. Here's like, building up terrain, all sorts of stuff like this. So we will be making a level editor for our project. Nothing this complicated, but we will be going into some of that tooling stuff as well. Just different videos here from level editors, from game engines. Game engines make things really easy. Some game engines have like these blueprints where you can do visual programming. So hey, I want this to like this texture and this shader trigger when this thing happens. It's all done visually. I think this might be Godot. I'm not 100% sure. So we will not be making a full Unity-like game engine. We will be making like the game engine that just plays the game and a level editor. Our game engine will have an ECS programming architecture written in C++. It will have a UI this year, so I have that in there as well. You'll be able to program many different 2D games very easily. You'll be able to incorporate different game scenes, so like we can have a menu, a pause screen, a gameplay scene really easily, and we'll make our own level editor for the project. And we could extend this to 3D, but the whole course would be just the annoying 3D stuff, so we're not going to do that for this course. Why not Unity or Unreal? This is a computer science class, not a game class. We really want to get our hands dirty with the details, talk about low-level optimization in some cases. So after this course, you will understand how those engines work. And because you understand how they work, or at least partly how they work, not the whole thing, you'll be able to use them and use them more efficiently, in my opinion. So if what we did was teach Unity, all I would be teaching you is syntax for Unity. So what if your job doesn't use Unity? I just wasted like 4 months of your life, right? Okay, you made a game, fine. But I want you to understand the low-level details of how stuff works. And in previous courses, I've like polled after the course, hey, now that the course is finished, are you happy that we did it the way we did? Or looking back, would you have liked to use Unity? And I think one person in the history of course has said, I would have liked to use Unity instead. So if you get taught how to use a specific game engine and the company you go to doesn't use it, Well, you've kind of not really learned a lot, right? If you get taught the underlying way that something works, you'll be able to learn any specific game engine easily and know even more about how it works than someone who just learned the engine itself. And this is applicable to like all of computer science in general. So one of the things that I keep hearing from computer science students all over the world, not so much here actually, which is nice, but everywhere, is that university did nothing to prepare me for my job, right? I went to my job and I had to learn everything there. It's like, yes, that's the point. We are not teaching you to get a job at company X. We're not teaching you Tesla's Git architecture or like Verafin's whatever, right? We are teaching you the fundamentals. And what you get out of an undergrad degree, in my opinion, is you have learned how to learn independently. And then when you get to a company, you have the fundamentals of knowing, oh yeah, I've used that algorithm before. I haven't used it in that programming language, so I'm still going to have to learn some things. But you hopefully have the mathematical and fundamental knowledge to be able to do the things at that company. Now, someone who maybe went out to a community college and did a 2-year intensive software engineering degree might go to the same company as you and immediately be able to pick something up because they use the same software. But trust me, within a couple of years at that company, you'll know more about it than they do because of the fundamentals that you have learned, in my opinion. It's different case to case, but it's the difference between learning a technology and learning how technology works, right? So the course topics, kind of went over this already. There's a lot of stuff that we learn, but it's really well integrated into the assignments, right? So you're never like doing one thing at a time. It's all these things are combined into a single game engine. So for ECS, Entities, Components, and Systems, this is the main architecture that we'll be using. It's surprisingly easy to learn as a concept. The implementation details sometimes can be a little bit tricky, but I think I've set it up in this course in a way that makes it easy. So we'll talk about the architecture of it, how to design a system using it, and then how to implement the system that you've designed. So the classes that we use for ECS, the structure, memory management, how we use it, the systems for gameplay mechanics, etc. We'll talk about some physics and math for games, all sorts of different things, collisions, bullets, all sorts of cool stuff. Gameplay programming, very, very basic AI, like patrol behaviors, follow behaviors, stuff like that. Excuse me. Entity interactions, dialogues if we have time. I want those in the project if there's time for that. Things like difficulty settings, game configuration files, game events and triggers, inventory, weapons, saving and loading games. We'll get into all of this as we go along. So the plan is to introduce C++ and SFML, have one intro assignment on that, then we'll introduce ECS game engine architecture, so there'll be no ECS in the first assignment. And while the course is not over, we introduce 4 or 5 new topics. Then we have an assignment where we make a game with those 4 or 5 new topics. Then 4 or 5 new topics, make a new game engine, or update the game engine with those 4 or 5 new things in it. Something very important is that this course is going to maintain, as we go, a balance between efficiency, usability, and learnability. So what do I mean by that? Efficiency is like, at the bare metal level of computers, how fast is this code? Could we do it faster? Could we do it with less memory? That's efficiency. Usability is how difficult is it to implement that thing? And learnability is, can I teach this to an undergrad class in a couple of months, right? So the course is really a balance of those things. And what we'll do is, we'll start off with the easiest way of implementing something, and then we're going to talk about more efficiency as we go with the course. Okay, so the second assignment, we're going to be doing ECS. It's not going to be the most efficient way to do it, but it's going to be the way that's the easiest so that you can just get your hands dirty with it, right? It's kind of like if I showed you what a vector was and how to use a vector, but you don't know what the underlying details of the vector are. It's still very useful if you don't know how it works. Like, I kind of know how a car works. Not really, but I can drive one, and it's still very useful to me, right? If I knew exactly what each nut and bolt in a car did, it's not going to make me a better driver. Well, maybe it would, I don't know. But I'm going to teach you like how to do something first, and then we'll go down into the details a bit later. And there are always trade-offs in any method, right? Any way you do anything. There's literal trade-offs between like algorithmic efficiency and memory, for example. And then there are other trade-offs versus like, yeah, I could do the second lecture on like hardcore memory pooling in C++, but you'd be like, what the hell is he talking about? Because I haven't taught all the other stuff yet, right? So as we go, it's going to ramp up, and you know, this may sound obvious, but you may say, why didn't you teach us the most efficient way first? It's because that, like, the extra stuff you need to know would have gotten in the way of that. So that's the reasoning for that. So, does the class officially end at 11:45? Okay, perfect. I thought it was 11:15. I was looking down here like, oh crap, we're done. All right, so what is ECS game programming? Why use ECS for games? Who has heard of ECS in a way that you kind of understand it already? Okay. So ECS stands for Entities, Components, and Systems. There's two overall architectures with ECS. They're kind of different. I'll explain the differences as we go. So entities, components, and systems, that's what we're using, where each of these things is really separate. And there's another way of doing this, I think, which Unity does it, which is like a little bit different. But I'll get into the differences of those. So what is an entity? An entity is literally any object in the game. Whether it's visible or not, an entity is something in the game. So it could be a player, a platform, tile, bullet, enemy, an enemy spawner, a particle spawner, a background. Anything in the game is an entity. So ECS is actually a software design paradigm. It's not specific to games, but it does work really well for games. And keep in mind that, like I said, there's no best way to do anything. So there will be companies out there, like for example, I know Overwatch uses the ECS architecture, right? So Overwatch, huge game by Blizzard. I know there are other games that those companies completely swear off ECS like it's the devil, okay? ECS, again, trade-offs. If you were just making like a checkers board game, you wouldn't use ECS for that, right? It's a little bit overkill. You just make an array, put the pieces in the array. But once you start getting into a game where you're going to have like multiple different scenes in the game, like you want a menu or something, when you have a bunch of different types of NPCs, maybe they have inventories and weapons and all this kind of stuff, that's where I would start to get into ECS, once your game like reaches a certain level of complexity. And this is sort of like ECS being better than saying object-oriented architectures. It's one of these like Windows versus Mac type of things, right? Like there's never a right answer, but what I will do is show you like an objective reasoning, and hopefully you see that through the programming assignments, why ECS offers us like a huge benefit. And it's also a cool thing to teach you for the course. It's called compositional-based architecture in comparison to an object-oriented architecture, which you could take and use for other things that are not just games. So in order to understand why ECS may be beneficial, we're first going to look at object-oriented design. So everybody here has done some sort of object-oriented programming, right? Hopefully, because it's a prereq. So object-oriented programming uses the concepts of objects and inheritance to implement specific functionality. So object-oriented programming is about, I have a base class, I have some derived classes, right? I have like functions that are interfaces or abstract classes. Like that's object-oriented programming. So OOP, as I'm defining it in this course, because there's many different definitions around, that's what I'm saying by OOP. It's actually how you implement something programmatically. Object-oriented design, especially when it comes to games, is the process of strictly using object-oriented programming in order to design the architecture of our game engine and the entities within it. So there's slightly different concepts. One is more architectural design related. The other one is like low-level implementation related. So what do I mean by this? So OOP and OO design helps us manage data and code. So for example, our entity in the game, let's say we're looking at Mega Man here, or a tile, each of them have an XY position, for example. It's a 2D game, so they all have a position at the very least. So if we use the entity as a base class, then we could have tile and player inherit from the base class. That's good object-oriented architecture. To have different things in your software system, notice the commonalities between them, make a base class with those common elements, and then have derived classes inherit from those things. So what we could have is something like an entity base class up on top, and then maybe we have a bunch of different things in our game. So this is really small, so I'll read it out. Over here maybe we have static entities that don't move, or we have dynamic entities that do move. So for example, a dynamic entity might have to have something like a velocity, whereas a static entity would just have like a sprite or a texture or something like that. So we've identified, okay, this is a new level of hierarchy in our object-oriented design where we split our entities again. Then when it comes to static things, maybe we have a rock class that inherits from a static entity, or a tree. Over here in dynamic entity, maybe we have an enemy, like a Goomba walking around a Mario level, or the player moving around. And so we see how complex this architecture gets. As we add more and more things, we're pretty much adding a new class for each new thing that we add. And then what if we have something that like, okay, I want a tree that's also an enemy. Okay, so maybe now I have to have static enemies and dynamic enemies, and like, it can get complicated, right? And yes, there are ways to do this that are a little bit nicer than this contrived example that I've given, but if you try to use strict object-oriented programming to manage your architecture, it gets very hierarchical and very difficult very quickly. So the entity component way of doing this is as follows. An entity, again, is just an object in the game, and then components are properties that we attach to entities. So you can think of as an entity as just a container that holds components. Okay? So some component examples might be a position, a speed or a velocity, a bounding box, health, weapon, damage. All of these things are components. And so what we have then is we have a collection of these components, and then we build entities from those components. Right? So rather than having this hierarchy of different things, what we have is a more horizontal type of architecture. So over here we have a position, right? So let's say we take that tree, like a static tree in our game. A static tree might have a position and a sprite. So sprite is just the graphical portion that we'll be drawing. So a tree just stands there all game, right? I have a position and I have a sprite. That's it. However, an enemy may have a position, an AI, a sprite, an axis-aligned bounding box, which we'll talk about later in the course, and a velocity. A player will have the same things as an enemy, except instead of an AI, it'll have controller input. Right? So you can see that we're going to have a bunch of different components, and then we just add these components and give them specific values that make them all the different things in the game. And to me, and hopefully you will see by the end of assignment 2, how really easy this makes things in the game. So ECS uses composition-based design. And so you have components, composition-based design. That's where it comes from. So an entity, again, is anything in the game. A component are properties that are attached to entities. So position, texture, animation, health, gravity, whatever, they're all components. And in this, what I call pure ECS, which is a term that, is How you define ECS, if you Google online, is weird and people have different definitions. I'm calling pure ECS the architecture where components only store data. So if you have a gravity component, it'll just store like -9.8 or whatever your gravity is in the game. The components do not store logic, okay? So in some entity components systems architectures, the components can have logical functions on the components that do the work for you, okay? We are not doing that. So components are pure data. All right, we'll talk, as we get through the course, we'll talk about the differences between those two things. So how do we do things with the data? We have systems. And so those systems are code and logic that drives the behavior. So we may have a function, and systems are just functions, right? So we'll have a function that does all the movement in the game. We may have a function that does all the rendering or all the graphics in the game. Another one that does the sound, another one that does the physics. And so we'll have different systems for different things in the game. And the cool thing, one of the benefits of this, is that, hey, we want to turn off the graphics, we turn off the rendering system. We want to turn off the collisions, we can turn off the collision system. It's really modular and really interesting. So here's an example. If you have a player, that player may have a position, a speed, a bounding box, a sprite, health, gravity, and input. Okay, so that would maybe make up the player in the game. An enemy may have a position, speed, bounding box, sprite, health, and an AI system, right, or an AI component. A bullet may have these things as well, but it may have a damage component. So for example, in our collision system, we would say, hey, if these two things have collided, do their damage component worth of health to each other, right? Also, we're going to have this lifespan system. So a lifespan, if I attach a lifespan of 2 seconds to this thing, once it's been created, our lifespan system will automatically destroy it once 2 seconds has passed, right? So like really easy ways to attach behaviors to entities using these components. But a tile might be really simple. Might just have a position, a bounding box, and a sprite. Okay. So one cool example that I did just to show this, and I'll show this once I get, I think, to assignment 3, is like, let's say I have a gun in the game that removes collisions from things. So if I have tiles in the game, and like I can jump on the tiles like in Mario or any other platformer, my gun, if the bullet hit the block, it would remove the bounding box component, and now I could move through the tile, right? Or if I had another thing called a gravity gun, and if I shot something with the gravity gun, it would just attach a gravity component to it, and now the block would fall, right? So like you can do all these sorts of things. You already have the system written for that thing, so the system will just say, hey, if this thing has gravity, do the logic for gravity. So what do the systems look like? Well, the movement system is one line of code. Like it may be more in practice, but what we would say is that the movement system would say, hey, for each entity, this is modern C++ for E and entities, take the entity's velocity and add it to the position. And you're done. You have just updated the position of every entity in your game by just adding its velocity to it. Right? So you don't need to have separate functions on each possible different thing. It'll just update it for you. Collision system might say, for example, for each bullet in my game, for each enemy in my game, if there's a collision between the bullet and the enemy, take the bullet's damage, subtract it from the enemy's health, and destroy the bullet. So this is what your code is going to end up looking like. Like really clean, component-based code. And then the rendering system, now obviously it'll be a little bit more complex than this, but we'll just say for each entity, window.draw the sprite of that entity at that position. That's it. So like really easy ways of doing these systems. Now of course, like the physics is collision, that's where the hard stuff is going to be. We'll have a whole lecture on that, but your code, like in my opinion, good code should read like pseudocode, right? And so if some people are of a different mindset where they would put all of the collision code right here, right? But I want you to be able to read this and completely understand what it's doing. So we'll talk about these software principles and stuff later, but the whole point is that these systems can be very, very easy to write and very, very powerful. And so the architecture that we'll have in the end, this won't be right away, but by assignment 3, I think we'll have this. So our game engine will have different scenes. So a scene would be something like a menu scene. It's anything where there's different logic happening, right? So in the gameplay scene, there's different logic, like hitting the buttons will do something different than in the menu scene. Each scene will have its own systems. So like the menu scene is going to handle your user input differently than the gameplay scene. And like the menu scene may not care about gravity or collisions or anything like that. It will have its own entity manager. So this entity manager is going to be a factory. Who's heard of a factory design pattern before? Okay, a couple people, that's good. What a factory is it handles all the logic of creating and destroying things for us. So we'll be able to say, hey, entity manager, create a new entity. And it'll just do it. And we won't need to worry about any memory management or anything. You'll be shocked at how little we have to worry about memory management using modern C++. And I'll get into all of that. So the entity manager will create and control and store all the entities, and the entities will store all the components. So this is the architecture that we'll have. It's really simple, really intuitive, and I think you'll get along with it. And you know, we have class diagrams and all that kind of stuff. I'll get into this more when we actually do the assignments. But they're pretty simple. So for example, our systems will have user input, animations, movement, enemy spawner, collision, rendering, events, all that kind of stuff. We'll have all systems for all that. And then our entities will eventually have functions like, okay, we can destroy an entity, we can add a component, we can get a component, we can remove a component, we can tell whether or not it has a component. We'll design all this from the ground up. And then an example of a component is a transform component. So in mathematics, a transform is like a scale or a rotation or a movement, and so that's what this is. So for example, a transform component of an entity would hold the position, this should actually say velocity, the scale, or the angle, right? So that's the entirety of a component. This is the entirety of a health component. What's my current hit points, and what are my max hit points? That's all you ever need to store, and then the system will take care of it, right? So this is pure data in the components. Okay, so the last thing I wanted to show is an example of where the engine will be going, and hopefully this runs. Okay, so I've taken this like to a different level that we will be taking it into the course, but I basically have different games and different things inside the same. So this is all in the same game engine, switching between different games. Okay, so we can switch between these different games. This is actually assignment 2. This is assignment 4. This is assignment 3. This is something else. But we can also have if I look down here, here is the user interface. This is extremely small. I apologize. The one annoying thing about this UI system is its ability to resize effectively. So, but if I go over here, for example, to assets, I can see all the different assets that I have loaded in my game engine and display them here as buttons. And so if you're thinking about making like a level editor, this is insanely powerful. To do this, it was like 4 lines of code, literally 4 lines of code to do that. It's crazy powerful. Also, if I look over here, I can have a little debugger for my entity manager. So I have entities, and we'll talk about entity tags. So a tag on an entity is like the type of thing. So a bullet would be a tag that we assign to a bullet entity, a tile, or a player, or whatever. So I go over here, and I look at tile. I can scroll down. Let me make this a little bit bigger. And I can see all the different tiles in my game, where they are. I can print all sorts of debug information. Here are the different NPCs in the game. Oh, look, I found a bug by doing this. So my Goombas walked off the side of the level, and they're now at like Y position 6 million because they're just falling because of gravity. So I didn't remove those entities, and there's a bug. All because I visualized things with a UI. Okay? So that UI, it's called IMGUI. It is insanely easy to use. Like, you'll be shocked at how easy this is. If you've ever used any other UI system, even in Python, this is easier. It's crazy. So yeah, so here I can like jump, I can shoot, and do all sorts of crazy stuff. In the Zelda game, I can, now we have hit points and stuff, so I can walk around and deal hit points of damage and take damage, and then like pick up hearts. You can see that this guy's trying to follow me here. So basic AI. Once we get to assignment 4, I think I can teleport if I walk into here. Yeah, so I can teleport different places. We can have certain entities, like there's a escape here somewhere. There we go. So like certain entities have bounding boxes, certain ones don't. Very easy to turn on or off with the ECS system. So you'll be making all of that. And it won't be as hard as you think. I think that's all I wanted to say. Any questions or anything about the course? Yep.
When do we start the project?
So, yeah, if I go back here, so the idea is that we build our game engine throughout the course. And you're kind of working on the project the whole course because of that. But I know what you mean, like the actual working on the project. So here in about a month and a bit, month and a half, is when I'm going to give out the sheet on the actual project information. Because if I give it now, you just haven't learned all the stuff, right? So this is around the time when you've learned enough to really know what you want to do for the project. And so then there will be 2 weeks later, the game proposal document. And then that will be, the project itself will be due on the last day of exams. Okay, so I'm giving you literally as much time as possible to work on the project. And so there will probably be overlap between when I give you the project and other assignments being due, right? Because, I mean, I could just wait until after the last assignment is due, but that would just give you less time to think about it. So yeah, there's a bit of at the end of the course here, so here's assignment 4. I give you a bunch of time to work on assignment 4, but all the stuff that you're doing for assignment 4 has to be in the project anyway, right? So you'll have, I think, about a month solid of no assignments and, of course, no exams in this course, at least, to work on the project and to get all that done. And then I have this down here just means that I always keep like a lecture free to move around in case some emergency happens. So that's what that is. Okay, any other questions, comments? All right, so I'll be putting a little survey on D2L about posting the lecture to YouTube. I don't think this is going to pick up like many people's voices, so I think you'll pretty fine with that. And after this, I'll see what the lecture capture gives us. Like for example, I'm super perfectionist when it comes to like audio visual stuff. So I'm going to take this, and I know that normally it's just posted to D2L with both cameras. I'm going to hide that, hopefully, download it, trim off the start and the end, because there's going to be 5 minutes of people leaving the room. Who wants that on a lecture, right? Nobody wants that. So I'm going to try. Now, halfway through the term, I may say screw it because it's too much work. But at least at the beginning, I'm going to try and download it and edit it a bit and stuff. So we'll see. Hopefully it's up to our standards.